Hi everybody, and welcome back to video number 2 in chapter 13. And when we left off, we were looking at illustrating an important conceptual point. Here we are taking the present value of an annuity at $9,000. We look it up in table 5.4, and we look it up at the prevailing interest rate, and the number of periods is 5 years. It's not what's written on the bond, which was 9%. So we multiply the $9,000 times the present value of an annuity factor, and we get the present value of all 5 of those $9,000 payments of interest. At the end of the period, we also take the present value of the $100,000 that we're paying back, and we go to table 5.2, again using the prevailing interest, and that gives us this factor, and the present value is $59,000. In this case, the present value is $92,608.10. But at maturity date, the investors are going to be repaid that entire $100,000. But this is the amount that they're going to pay today for that bond. Okay? And that discount compensates them for 11% instead of what's written on the bond, which is 9%. Okay, so now when bonds are issued at par and the stated rate and market rate are equal, if you go through this arithmetic, there's going to be no premium or discount. And that happens when the bonds are, quote unquote, issued at par. Also, if the bonds are issued on an interest payment date, no interest is accrued. The company simply records the cash proceeds and the face value of the bonds. That last sentence will be clearer as we go through this chapter. So here's an example. In order to fund improvements to the brewing process, Green Tea Company issues at par 10-year term bonds with a par value of $800,000 dated January 1, 2025, bearing interest at an annual rate of 10% payable semi-annually on January 1 and July 1. What entries does Green Tea make in 2025 related to this bond issue if the market interest rate is the same, 10%? Okay, so to record the issuance of a bond, we're going to receive the cash on January 1, 2025, so we'll debit cash and credit the liability bonds payable here. Then on our first semi-annual interest payment, we'll take 10% of $800,000, which is $80,000, and it's semi-annually, so we'll divide it by 2 or multiply by 6/12 to get $40,000 interest expense as a debit, and we credit cash for $40,000 to pay for it. Now, every now and then, we're gonna issue at par and record accrued interest expense. And here in December 31, we don't pay that interest for one more day, which would be January 1, 2026. So at the end of the year, we need to accrue for that interest expense, and they're accruing for the entire $40,000 as interest expense here. But the credit is to interest payable because we have not yet paid it in cash. One day later, we'll pay it in cash, and then we'll debit interest payable and credit cash. Okay, so to verify the price of this bond, we can go through the arithmetic again. And here, this was a 10% bond. So you'll notice that they're using 5% here. That's half of 10% because it's semi-annual. But they've doubled the number of periods from 10 years to 20 periods, right? So we look that up in table 5.2. We know we got to pay back that entire $800,000 at the end of 10 years. And so the present value of that's going to be $301,512. Now the present value of the interest payment, we're going to have $40,000 paid twice each year. And so again, we're going to use 5% in 20 periods, but this time we'll go into the present value of an annuity table in table 5.4, and we get this factor of 12.46221. Multiplying times $40,000, we get $498,488. If we add the $301,512 to the $498,488, we get exactly $800,000. And that is how we price a bond and why that bond is worth $800,000. It's the present value of all the annuity of the interest payments and the present value of the $800,000 when we pay it back at the end of the term. Okay, important concept. Okay, bonds issued at discount or premium on the interest date. So if Green Tea issues that same $800,000 bonds on January 1 at 97. Now, that 97 doesn't mean 970,000. It means 97% of par. So if I take 97% of 800,000, I'm going to get 776,000. That's how much cash I received for selling that bond. The discount was 24,000. So that's a debit. And we will always credit bonds payable for what's written on the bond. Okay, the face value, 800,000. Even if those bonds are issued at a discount or premium. So recall from our earlier discussions that because of its relationship to interest, companies amortize the discount and charge it to interest expense over that period of time that the bonds are outstanding. First, we're going to look at the straight line method. That's what I will tell you frankly what I've always used because it's simple and not quite as theoretically correct as the effective interest method, but it gets the job done. So the straight line method is going to amortize a constant amount in each interest period, in this case 20 interest payments. So what we do is we take the cash, we're going to credit cash for 40,000. That's what we're actually paying in cash. But the discount amortization, we take the 24,000 and divide it by 20, and that gives me $1,200. So our interest expense then is $41,200, different from what we paid in cash. Using the straight line method, that journal entry is the same in December as it was in July. Okay, now, straight line amortization premium. Let's take a look at this. Green Tea dates and sells the 10-year bonds with a par value, this time at a premium. So at 103. Again, 103 is a percentage. So we take 800,000 times 1.03. That gives me $824,000. We'll debit cash for that. The credit, the bonds payable, still remains what we're going to be legally obligated to pay at maturity, which is $800,000. The difference this time is a credit of $24,000. So when we debit or we credit cash for $40,000 to pay that semi-annual payment, the premium this time is going to be a $1,200 debit, which reduces our interest expense to $38,800. And that's how we would record that semi-annual payment. Now you'll notice here on December 31st, it's interest payable, not cash, only because we're not paying that until 1 January, 1 day later. Okay, so we're accruing that interest expense at the end of December. Okay, now this is a little confusing, I think. Here, we're going to issue bonds between the interest dates. So in this case, they're saying March 1, we issued the 10-year bonds at par, same conditions. It was dated January 1, 2025, with a par value of $800,000. These bonds have an annual interest rate of 6% payable semi-annually on January and July the 1st. What entries do we make? Okay, so in this case, we have $800,000 is going to be our bonds payable, just like we did before. But we have interest expense we're going to recognize on March 1 to the tune of $8,000. That's $800,000 times 6% times 2/12. That's January and February. So you'll notice that's a credit to interest expense, which is a negative expense. So then on July 1, when we actually pay our interest payment, we'll debit interest expense for the full $24,000 and credit cash for the full $24,000. So in effect, the purchaser advances 2 months of interest. On July 1, 4 months after the date of purchase, Green Tea pays the purchaser 6 months of interest. So that offsets this interest expense by $8,000, which leaves us with a debit balance in interest expense of $16,000. And that represents the proper amount of interest expense for 4 months. Pretty straightforward there. Okay, so now here we're going to issue between interest dates, but this time we're going to be issuing at 102%. So 102% plus an additional $800,000 times 6% times 2/12. Instead of, it will be at $824,000. Bonds payable, again, will be $800,000. The premium on bonds payable will be $16,000. And that's $800,000 times 2% here. And the interest payable, the interest expense payable, which is going to be a credit in this case, is $8,000. Then when we actually record the interest expense is going to be $23,457.63. Again, the cash will be $24,000 that we pay. But this premium on the bonds payable, we're going to take, instead of 120 periods, which would be 10 years times 12 months, it's 118, 2 months short of that. So we take 16,000 divided by 118 times the 4 months. That calculation's a little tricky, so be sure you understand it. So that gives us the correct answer here for this solution. And that looks like a good place for us to stop this video. And when we return, we'll finish